All right, today we're doing something pretty cool. We're going to build a digital fortress. We're talking about how you can protect your absolute most sensitive data, things like private keys, secret passwords, personal info, in a way that's, well, pretty much untouchable. So let's get right into it.
So here's the big question, right? On any normal server, even when you've locked down tight, if someone, an admin or worse, an attacker, gets that top-level root access, it's game over. They can see everything. For the really, really critical secrets, that's just not good enough. We need a totally different way of thinking. And that different way of thinking is the AWS Nitro Enclave. Now, this isn't just some new software firewall. This is a totally isolated environment, locked down by the hardware itself. The best way to think of it is a secure vault built right inside your server. I mean, this thing has no disk, no network connection, and there's absolutely no way for anyone, not even you, to log into it. The only way to talk to it is through a single, super secure private channel.
So how do we make a vault like that completely impenetrable? Well, you wouldn't protect a real vault with just one flimsy lock, would you? Of course not. We use a strategy called defense in depth, which is all about building multiple, overlapping layers of security. This whole strategy breaks down into 5 distinct layers. We start right at the bedrock, the hardware itself, and then we stack security all the way up to the application that manages who gets in. Each layer has the other's back, creating this incredibly tough barrier to break through. So let's see what each of these layers actually does. Every single piece here has a very specific job. The hardware gives us that physical separation. AWS KMS is our heavy-duty encryption engine. S3 is our super durable vault, where we keep the encrypted data. VSOCK, that's our secure communication pipeline. Think of it like a private encrypted phone line that only the server and the enclave can use. And finally, IAM is our gatekeeper, the bouncer who decides who gets to use that phone line in the first place.
Okay, with the blueprint in hand, it's time to get our hands dirty. Let's start by laying the foundation. We need to get the core AWS services set up that are going to support our digital vault. First thing we need, a master lock. And that's where AWS Key Management Service, or KMS, comes in. This isn't your average lock, though. It uses these special, tamper-resistant pieces of hardware called security modules to protect its own keys. It's like a tiny Fort Knox for your encryption keys. Plus, it gives us powerful tools like envelope encryption and a full audit trail of every single time a key gets used. Next, we need a safe place to actually store our encrypted private keys. For that, we turn to Amazon S3. And this isn't just some random folder on a drive, okay? This service is ridiculously durable, it automatically encrypts any file you put in it, and it even keeps past versions of files to save you from any oops moments. It is the perfect secure deposit box. So we've got the master lock and the deposit box. How does our server get permission to use them? Well, we're definitely not going to give it a permanent key that can get lost or stolen. No way. Instead, we use an IAM role, which is basically like a smart security guard. It hands out temporary passes that expire and get refreshed automatically, and these passes only grant the exact permissions needed to do a job, and absolutely nothing more. That's the principle of least privilege, and it's so important. And this security guard has a very strict set of instructions, which is called an IAM policy. If you translate it from text speak to plain English, it's super simple. This policy gives our server just 3 specific permissions. 1, permission to use our master key in KMS. 2, permission to see what's inside our S3 bucket. And 3, permission to read, write, and delete the encrypted files in there. That's it. Explicit, limited, and secure. All right, the foundation is poured. Now it's time to actually assemble the secure room where our vault is going to live. And this means getting our main computer instance ready to go. Now, listen up, because this part is so important. You can't just grab any old server. It absolutely has to be an instance type that's built on the AWS Nitro system. And you see that last one? This is the big one. You have to enable the Enclave feature when you first launch it. Let me say that again, because this is the one step that trips people up all the time. This feature cannot be added later. If you miss that one little checkbox during setup, you have to tear the whole thing down and start over with a brand new instance. It's a non-negotiable, foundational step. So once our special instance is up and running, we do a bit of prep work. You know the drill. Slap on the latest security patches, get Docker installed so we can neatly package our application, and then install the special command line tools that let us manage the Enclave. And finally, we literally carve out a dedicated slice of CPU and memory just for the Enclave to use. It gets its own private resources. Okay, The vault is built, the guards are at their posts, the room is secure. Now for the really cool part. Let's see how this whole thing actually works when a request comes in.
The entire life of an enclave is designed for maximum security. A request comes in, and only then does the enclave even blink into existence. It does its one sensitive job, creating or using a key, sends back the result, and then poof, it's completely destroyed, along with everything that was in its memory. Nothing is left behind. It's a ghost. Let's watch this happen. A user, let's call them user 1, makes their first request. The system immediately spins up a brand new, clean enclave. Inside that isolated space, it generates a new private key. Then it uses that secure channel to ask KMS to encrypt the key. It stores that encrypted blob in S3, and it sends a success message back to the user. Now, the same user comes back for a second request. Again, a fresh enclave pops into existence. This time it fetches the encrypted blob from S3 and passes it through the secure channel to KMS. And here's the magic trick. KMS decrypts it, but the unencrypted key is only ever revealed inside the secure memory of the enclave. Once the job is done, the result is sent back, and that enclave, along with the plaintext key inside it, is instantly wiped from existence. And that right there, that's the ultimate payoff. That's the mic drop moment. The raw, unencrypted, super-sensitive private key exists for maybe a few milliseconds inside a hardware-isolated box that no one can get into, not even the most powerful user on the machine. This is how we meet that impossible goal from the beginning. So, we've just walked through how to build a truly secure digital vault using Nitro Enclaves, but this technology is way bigger than just crypto keys. Think about it. You could use this for processing sensitive medical records, handling financial transactions, or protecting secret machine learning models. It really opens up a whole new world for confidential computing, which leaves us with one final thought. Now that you know how to build the vault, what priceless secrets are you going to protect inside it?